Hi guys, welcome back to Rose Lil channel. Today we will discuss about chapter 2 similar triangles. We'll do a complete revision of this chapter. So initially we'll start with the basic formulas or basic understanding of the chapter. First, if they give a triangle ABC, and in that triangle if DE is parallel to BC, then we'll take this is a triangle ABC, and they are given that DE a line is parallel to this BC. Then Thales theorem states that AD by DB is equal to AE by EC, and corollary of Thales theorem states that AD by DB is equal to AE by EC, AE by AC, that is equal to DE by BC. This can be written in one more way, same corollary of Thales theorem. This is equal to DE by AB is equal to EC by AC. This kind of corollaries can be used in proving questions. So we'll take one more triangle. In triangle ABC, if they give this triangle is proportional to triangle PQR, then we will take two triangles here, ABC. We will draw a line. This is a right angle triangle AMC. We will take one more triangle which is proportional to this ABC, that is, we will draw a line here, and this PNR is a right angle triangle. So area of triangle ABC by area of triangle PQR is equal to AB by PQ whole square. This is equal to BC by QR whole square. This is equal to AC by PR whole square, which is equal to AM by PN whole square. When they ask you the area of triangle ABC divided by area of PQR, you can use any of these formulas. We'll move into the next formula. In right angle triangle ABC, if angle ABC is equal to 90 degree, we'll take a triangle ABC. This angle is 90 degree. Then this is nothing but Pythagoras theorem. AC square is equal to AB square plus BC square. This is the Pythagoras theorem. Last formula of this chapter, Pythagorean triplets. Three, 4, 5. These are called Pythagorean triplets because 3 square plus 4 square is equal to 5 square. When you do the square of the first two numbers, if you get that number is a square of the third number, we will say that three numbers are Pythagorean triplets. So on 6, 8 and 10. 64 plus 36 is equal to 100. 5, 12 and 13. 5 square plus 12 square is equal to 13 square. Same with 8, 5 and 17. 8 square is equal to 8 square plus 15 square is equal to 17 square. 12, 16 and 20. 12 square plus 16 square is equal to 20 square. 10, 24 and 26. 10 square plus 24 square is equal to 26 square. Now I will focus on the important questions of this chapter. We will start with the 1 mark questions. In this, some I will solve, some I will leave it as incomplete. If you get any doubts in these questions, put that in comment section, I will answer that. So we'll start. In the adjoining figure, DE is parallel to BC. Value of x, they are asked. They are given a triangle ABC. Here DE is parallel to BC. This is 1 centimeter. This is 3 centimeter, and this is 1 centimeter. You have to find the value of x. X is nothing but BC. The answer of x is 4 centimeter. Second question. If perimeters of two similar triangles are in the ratio 5:4, ratio of their corresponding sides. The answer is 5:4. Third one. The sides of triangle are 3, 4, 6 units. The corresponding side of another triangle similar to this are. The answer is 9, 12, 18. Fourth one. At a certain time of the day, a man 6 feet tall casts his shadow 8 feet long. At the same time, length of shadow cast by a building "45 feet high is." The answer is 60 feet. Fifth one. Ratio of corresponding sides of two similar triangles is 2:1. Ratio of their areas. Ratio of their areas is 4:1. Answer is 4:1. The question is reverse here. Ratio of areas of two similar triangles is 16:81. Find the ratio of their corresponding sides. The answer is 4:9. Which one of the following does not represent sides of a right triangle? Check with all whether if you cannot apply Pythagoras theorem to any of the sides, then that three sides are the one which does not represent the side of a right triangle. The answer here is 3, 6 and 8 centimeter. You cannot apply Pythagoras theorem here. This is 9, this is 36 and this is 64. Square of this. 8th question. Side of a square is 12 centimeter. Length of its diagonal. The answer is 12√2 centimeter. 9th one. Length of diagonal of square is √50 meter. Its side is. The answer is 5 meter. In triangle ABC, AB is equal to 6√3 centimeter, AC is equal to 12 centimeter, BC is equal to 6 centimeter. We have to find angle B. The angle B is 90 degree. Last 1 mark MCQ. Height of an equilateral triangle whose side two A units is. The height of this is √3A units. We move into the 12th question. 12th question. State Thales theorem. If a line is drawn parallel to one side of a triangle, to intersect the other two sides, in distinct points, the other sides are divided in the same ratio. Thirteenth question. State Pythagoras theorem. Pythagoras theorem states that in right triangle square of the hypotenuse is equal to sum of the square of other two sides. Fourteenth question, converse of Pythagoras. In a triangle, if square of one side is equal to sum of the squares of other two sides, then the angle opposite to first side is a right angle. Write the two conditions for two polygons of same number of sides to be similar. The conditions are all the corresponding angles of polygon are equal and all the corresponding sides are in the same proportion. State converse of Thales theorem. Converse of Thales theorem states that if a line divides any two sides of a triangle, in same ratio, then the line is parallel to the third side. Last one more question. The areas of two similar triangles are in the ratio 4:9. Find ratio of corresponding medians. The answer is 2:3. Let us move into the 2 mark questions now. We'll start with the 2 mark questions. 18th question. In the figure, D is parallel to BC. You have to find EC. They are given a diagram. To find this, what is EC? We know by Thales theorem ED by dB is equal to AE by EC. This is by Thayer's theorem. We substitute the values. AD is given as 1.5, dB is given as 3, AE is 1. Find EC. EC is nothing but 2 centimeter. Nineteenth question. One figure is given and DE is parallel to BC. Find AD. Similar kind of question. This is 7.2 centimeter. This is 1.8 centimeter. This is 5.4 centimeter. 20th question. Triangle ABC. D is parallel to BC. AD is equal to x plus 1. DB is equal to x minus 1. AE is equal to x plus 3. And BC is equal to x. Find the value of x. I will draw the diagram. ABC. D is given as parallel to BC. This is x minus 1. This is x. This is x plus 3. This is x plus 1. To find the value of x. 21st question. AQ is perpendicular to AB. PB is perpendicular to AB. AD is given, that is 20 centimeter. BD is 12 centimeter. PB is equal to 18 centimeter. Find AQ. They are given as a diagram. QA. Both are right angles mentioned in the question. This is P, this is D, A and Q. You have to find this AQ. 22nd question. PS by SQ is equal to PT by TR and angle PST is equal to angle PRQ. You have to prove that triangle PQR is isosceles triangle. Proof. You have to prove PQR is isosceles. Moving to the 23rd question. A vertical pole of height 6 meter casts a shadow 4 meter long on the ground. And at the same time a tower casts a shadow 28 meter long. Find the height of the tower. Let triangle ABC is proportional to triangle DEF and the areas are given. 64 centimeter square and 121 centimeter square. If EF is equal to 15.4 centimeter, find BC. I'll solve this. Triangle ABC is given as proportional to triangle DEF. So area of triangle ABC divided by area of triangle DEF is equal to BC by EF whole square. Substitute the value of areas and you will get the value of answer BC is equal to 11.2 centimeter. Area of triangle is 64, area of triangle DEF is 121, EF is 15.4. Substitute that and you will get the answer of BC is equal to 11.2 centimeter. 25th question. D is parallel to BC, AD is to DB, that is 5:4. Find ratios of areas of triangle ADE and triangle ABC. They are given a triangle, same to prove Thales theorem, ABC D. Find the ratios of areas of triangle AD and DBC. AD and ABC. AD is to DB value is given, that is 5:4. Now let us move into 26th question. Diagonals of a trapezium ABCD with AB parallel to CD intersect each other at point O. AB is given, that is 2CD. Find ratios of areas of triangle AOB and triangle COD. We will draw trapezium. This is given that AB is parallel to CD and they both intersect each other at this point O. So we will solve this. We have to find the ratios of triangle AOB and triangle COD. Here it is given AB is equal to 2CD. So AB by CD is equal to 2 by 1. Take this as first equation. In triangle AOB and triangle COD, angle A is equal to angle C because they are alternate angles. Angle B is equal to angle D because they are also alternate angles. So triangle AOB is proportional to triangle COD by angle similarity criterion. So area of triangle AOB by area of triangle COD is nothing but AB by CD whole square. This is by theorem of areas. So we'll get that 2 by 1 whole square, 2 by 1. 27th question. Diagonals AC and BD of trapezium ABCD AB is parallel to CD intersect each other at point O. Prove that OA by OC is equal to OB by OD. Proof. 28th question. triangle ABC, D is a point on BC such that triangle angle ADC is equal to angle BAC. You have to prove that CA square is equal to CB into CD. Proof. I'll draw the triangle. AB, D, C. Now we'll move into 3 mark questions. 29th question. Prove that sum of squares of sides of a rhombus is equal to sum of squares of its diagonals. We'll first draw a rhombus. Here it is given that sides of a rhombus are equal. So diagonals AC and BD intersect perpendicular to O. Angle AOB is 90 degree. In right angle triangle AOB, this right angle triangle AOB, AB square is equal to AO square plus BO square by Pythagoras theorem. AB square, this AD is nothing but half of AO is nothing but half of AC. AO is half of AC. Write that, substitute that in place of AO. BO is nothing but half of BD. Substitute that, and you will get 4AB square is equal to AC square plus BD square. Nothing but AB square plus AB square plus AB square plus AB square is equal to AC square plus BD square. Instead of AB, again all the sides are equal. Substitute, instead of one AB, all the other 3 ABs are other sides of a rhombus. You will get the proof. AB square plus BC square plus CD square plus DA square is equal to AC square plus BD square. This is because it is given in the question all the sides of a rhombus are equal. We will move into 30th question. 30th question. Two poles of heights (6 meter and 11 meter) stand on a playground. If the distance between the feet of the poles is 12 meter, find distance between the tops. Thirty-seventh one, 31st one. The perimeter of right angle triangle is 20 centimeter and the sides containing right angle are in the ratio 4:3. You have to find the sides. 32nd one. ABC is an isosceles triangle with AC is equal to BC. AB square is equal to 2AC square. You have to prove that triangle ABC is right triangle. Third one. In figure, ABC and DBC are two triangles on the same base BC. If AD intersects BC at O, show that area of triangle ABC by area of triangle DBC is equal to AO by DO. I'll draw the diagram. AB, this is O, this is C, and this is D. 34th question. In a quadrilateral ABCD, diagonals intersect at O if AO by BO is equal to CO by DO. Prove ABCD is a trapezium. This is a trapezium. A, this is O, B, C, and D. Thirty-fifth question. In equilateral triangle, prove that 3 times square of one side is equal to 4 times the square of one of its altitude. We'll take a equilateral triangle here, ABC. This is the right angle, D. You have to prove 3AB square is equal to 4AD square. 3AB square is equal to 4AD square. That is given in the question. In triangle ABD and triangle ADC, we know angle D is equal to D. That is equal to 90 degree, which is given. AB is equal to AC, that is also given. AD is equal to AD, that is common side. This is given and this is given. So triangle ABD is proportional to triangle ADC. This is by RHS postulate. That implies BD is equal to CD that is half BC. Consider this as first equation. Now in right angle triangle ABD, this triangle ABD, AB square is equal to AD square plus BD square. Pythagoras theorem. AB square is equal to AD square. Instead of BD, substitute that as half BC. By first equation, we will get AB square is equal to AD square plus BC square by 4. Take common, then bring it to other side. You will get 4AB square minus AB square is equal to 4AD square. This is nothing but 3AB square is equal to 4AD square. This is asked to prove. Now we will move into the 36th question. 36th question. BL and CM are medians of triangle ABC. Right angled at A. Prove that 4 into BL square plus CM square is equal to 5BC square. I will draw the diagram. C, this is L, this is M, this is A. This is given right angled at A. From triangle ABC, you can take that BC square is equal to AB square plus AC square. This is by Pythagoras theorem. In triangle ABL, this triangle, you can write BL square is equal to AL square plus AB square. This is also same by Pythagoras theorem. Instead of AL, substitute that as AC by 2 and we will continue. AC by 2 whole square plus AB square. We will get 4BL square is equal to AC square plus 4AB square. Consider this as the second equation. Consider this as first equation. Now from triangle CMA, CM square is equal to AC square plus AM square. This is by Pythagoras theorem. Substitute instead of AM, substitute that as AB by 2. CM square is equal to AC square plus AB square by 4. Substitute AM as AB by 2. We will get 4CM square is equal to 4AC square plus AB square. Consider this as the third equation. Now we will add equation 2 and 3. 4BL square plus 4CM square is equal to AC square plus 4AB square plus 4AC square plus AB square. Take 4 as common. 4BL square plus CM square is equal to 5BC square. AB square plus BC, AB square plus AC square you will get when you take 5 as common in this side. That AC square plus AB square is nothing but BC. This is from equation 1, that is Pythagoras theorem. 37th question. 37th question. D and E are points on side CA and CB respectively of triangle ABC, right angled at C, prove that AE square plus BD square is equal to AB square plus DE square. I will draw that. This A, this is right angled at C, B, this E, this is D, now from triangle ABC, AB square is equal to AC square plus BC square. Consider this as first equation. This is by Pythagoras theorem. In triangle ACE, AE square is equal to AC square plus CE square. Consider this as second equation. This is by Pythagoras theorem. Triangle BCD, BD square is equal to DC square plus BC square. Consider this as third equation. Same Pythagoras theorem. And last, in triangle DCE, DE square is equal to DC square plus CE square. Fourth equation by Pythagoras theorem. Now adding 2 and 3, we will get AE square plus BD square is equal to AC square plus CE square plus DC square plus BC square. That simplifies as AE square plus BD square is equal to, instead of AC square plus BC square, we will write it as AB square. That is by equation 1. And instead of CE square plus DC square, C square and this DC square, we will write this as DE square. This is from equation 4. We will get what they asked to prove. Now we will move into the 38th question. 38th question. A ladder reaches a window which is 12 meters above the ground on one side of street, keeping its foot at the same point. Ladder is turned to the other side of the street. To reach another window (9 meters) high. Find out the width of the street if length of ladder is 15 meters. We will draw the diagram. This is given as 15 meters, this is 12 meters, this is 15 meters, and this is 9 meters. We have to find this distance. You know from triangle ABE, BE square is equal to AB square plus AE square. That is by Pythagoras theorem. Substitute 15 in place of BE and AB as 12. You will get AE square is equal to 9 square. AE is 9 meter. Consider this as the first equation. Now from triangle CDE, DE square is equal to CD square plus EC square by Pythagoras theorem. substitute D is equal to 15 and CD has 9, you'll get EC square is equal to 12 square. EC is nothing but 12 meter. Second equation. Now AC is nothing but AE plus EC, 9 plus 12, that is 21 meter from equation 1 and 2. So the width of the street is 21 meter. Now we will move into the 4 or 5 mark questions. These are proving questions. 39th question. State and prove Thales theorem, or this question can come in one more form, that is basic proportionality theorem. First you have to write the Thales theorem. I have written in one more questions. If a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. We will draw a triangle here, ABC, where D is parallel to BC. We will do constructions to prove this theorem. We will take join DC and join BE. We will take a line here, that is N, which is perpendicular, and here it is a perpendicular M. To prove AD by DB is equal to A by EC, we know that triangle ABC D is parallel to BC by Thales theorem. We have to write the constructions. We have drawn DM is perpendicular to AC and EN is perpendicular to AB. Join BE and join. Now I start with the proof. Area of triangle ADE by area of triangle BDE is equal to half into AD into EN by half into DB into EN. This by the formula area of triangle half into base into height. When we cancel out, we will get that is equal to AD by DB. Consider this as the first equation. Area of triangle ADE by area of triangle CED is equal to half into AE into DM by half into EC into DM by same formula half into base into area of triangle, that is equal to AE by EC. Now both triangle BDE and CED are standing on the same base DE, and D is parallel between BC. So area of triangle BDE is equal to area of triangle CED. Consider this as third equation. Now from equation 1, 2 and 3 we can write AD by DB is equal to AE by EC. This is the Thales theorem. Now we will move into the 40th question. 40th question. We have to prove angle similarity criterion. We will first write what does this mean. If in two triangles corresponding angles are equal, then their corresponding sides are in same ratio. Hence, you have to prove that two triangles are similar. We'll take two triangles for this proof. We'll take triangle ABC and triangle DEF, and we'll draw a construction here. PQ, this angle is equal to this angle is equal to this, and this angle is equal to this. I have to write the given in both this triangle ABC and triangle DEF. Angle A is equal to angle D, angle B is equal to angle E, angle C is equal to angle F. Now, to prove AB by DE is equal to BC by EF is equal to AC by DF. Write the construction. Mark points P and Q on DE and DF such that DP is equal to AB and DQ is equal to AC. DQ is equal to AC. Join PQ. We start with the proof. In triangle ABC and triangle DPQ, angle A is equal to angle D. This is given. AB is equal to DP by construction, and AC is equal to DQ, that is also by construction. So we can write triangle ABC is proportional to triangle DPQ, that is by SAS postulate. Therefore, BC is equal to PQ by congruent parts of corresponding triangles. Angle B is equal to angle P by same CPCT. Angle B is equal to angle E, that is by given, that is data. Therefore, angle P is equal to angle E by axiom 1. This implies PQ is parallel to EF. Now we will use corollary of Thales theorem. dP by dE is equal to PQ by EF is equal to DQ by DF by corollary of Thales theorem. So that implies the required proof AB by DE is equal to BC by EF is equal to AC by DF, that is from equation 1 and by construction. We'll move into the 41st question now. 41st question, to prove the areas of similar triangles. We'll write the statement. Ratio of areas of two similar triangles is equal to square of ratios of their corresponding sides. We'll take two triangles here, ABC, M, this is PQR, this angle N, the right angle. Now what is given? Triangle ABC, triangle PQR is proportional. That implies AB by PQ is equal to BC by QR, which is equal to AC by PR. Now what we need to prove? Area of triangle ABC by area of triangle PQR is equal to AB by PQ whole square, which is equal to BC by QR whole square, which is equal to AC by PR whole square. We'll write the construction. Draw AM perpendicular to BC and PN perpendicular to QR. We start with the proof. Area of triangle ABC by area of triangle PQR is equal to half into BC into AM by half into QR into PN. This by using half into base into height formula. This gives us BC into AM by QR into PN. Consider this as first equation by cancelling half. Now in triangle ABM and triangle PQN, angle B is equal to angle Q. This is because we have known that triangle ABC is proportional to triangle PQR, and angle M is equal to angle N, which is 90 degree by construction. This implies triangle ABM is proportional to triangle PQN. This is by angle similarity criteria. That implies therefore AM by PN is equal to AB by PQ. Consider this as second equation. Now we know by data that AB by PQ is equal to BC by QR is equal to AC by PR. This third equation, that is by data. Now area of triangle ABC by area of triangle PQR is equal to AB by PQ into AB by PQ. This by substituting equation 2 and 3 in first equation, which gives us AB by PQ whole square. Now from 3 we can write area of triangle ABC by area of triangle PQR is equal to AB by PQ whole square is equal to BC by QR whole square is equal to AC by PR whole square. This is by the third equation. Now we'll move into the 42nd question. 42nd question. State and prove Pythagoras theorem. Statement is already written in 1 mark questions. I will continue with the proof. Take a right angle triangle ABC. Do a construction here. We know given that ABC is right triangle with B is equal to 90 degree. Even for all the theorems, you have to write first what is given, then you have to write what is to prove, then you have to write about the construction, then you have to start with the proof. First initially statement, then whatever the required diagrams, then you have to write the given part, to proof part, then construction, then you have to start with the proof. Each part carries marks. Now to prove AC square is equal to AB square plus BC square. Construction, what you have done, just we have drawn a BD that is perpendicular to AC. Now we will look into the proof. In triangle ADB and triangle ABC, angle D is equal to angle B, that is 90 degree, by data and construction. That is nothing but given. Angle A is equal to angle A, that is by common angle. Triangle ADB is proportional to triangle ABC. This is by angle similarity criteria. This becomes AD by AB is equal to AB by AC. This by proportion of sides. So that gives AC into AD is equal to AB square. Consider this as the first equation. Similarly, in triangle BDC and triangle ABC, angle D is equal to angle B, that is 90 degree, that is by data and construction. Same. Angle C is equal to angle C, this is by common angle. Triangle BDC is proportional to triangle ABC. Angle similarity criteria. That gives DC by BC is equal to BC by AC, that is by proportional sides. So you can write AC into DC is equal to BC square. Consider this as the second equation. Now we will add equation 1 and equation 2. By adding equation 1 and equation 2, we will get that AC into AD plus AC into DC is equal to AB square plus BC square. We will take AC common. AD plus DC is equal to AB square plus BC square. This AC square, AD plus DC is nothing but AC. This AC square is equal to AB square plus BC square. This is the proof of Pythagoras theorem. Now we will move into the 43rd question. 43rd question. This you have to prove converse of Pythagoras theorem. I'll write the statement. It is already there in 1 mark questions. We'll continue with the proof. We'll draw two triangle ABC and right angle triangle PQR. This angle, this side is equal to this side, and this side AB is equal to PQ. The converse of Pythagoras states that in a triangle, if a square of one side is equal to the sum of the squares of the other two sides, then the angle opposite to the first side is a right angle. So we'll write given triangle ABC, AC square is equal to AB square plus BC square. To prove angle B is 90 degree. We'll write the construction. We have constructed another triangle PQR right angled at Q such that PQ is equal to AB and QR is equal to BC. We'll start with the proof. In triangle PQR, PR square is equal to PQ square plus QR square. This is because angle Q is equal to 90 by Pythagoras theorem. PR square is equal to AB square plus BC square. This is by construction what you have done. Consider this as first equation. AC square is equal to AB square plus BC square. This is by given data. Consider this as second equation. Therefore, angle AC is equal to angle PR. Consider this as third equation. This is from first equation and second equation. Now, in triangle ABC and triangle PQR, AB is equal to PQ. This is by construction. BC is equal to QR. This is also by construction. AC is equal to PR. This is from equation 3. Now, therefore we can say that triangle ABC is proportional to triangle PQR. This is by side congruence. Therefore, angle B is equal to angle Q by corresponding parts of congruent parts of corresponding triangles. We know that Q is equal to 90 degree, that is by construction. So therefore angle B is equal to 90 degree. Already we know that Q is 90 degree, Q is angle B, so angle B is equal to 90 degree. This ends the revision of chapter 2. If you like this video, please like, share and subscribe, and all the best for your exams. Thank you.